A simple electric motor has an armature resistance of 1 ohm and runs from a DC source of 12 volts. When running unloaded, it draws a current of 2 amperes. When a certain load is connected, its speed becomes 1/2 of its unloaded value. What is the new value of the current draw? All right. So here we have a motor. Basically, a motor is nothing but having an armature carrying current in a magnetic field. The resistance of this armature is 1 ohm, and this entire thing is connected to a 12-volt battery. Right? This is rotating with basically slip rings and all. Right? Now, the resistance is only 1 ohm, whereas EMF applied is 12 volts. Ideally speaking, the current passing through it should be 12 amperes. But how much current is flowing through it? Only 2 amperes is flowing. That is because when the armature is rotating in a magnetic field, it creates a back EMF. Let's call that EMF as E. So net EMF is 12 minus E divided by 1 ohm is 2 amperes. Or we can say back EMF developed is 10 volts when it is running at an angular speed of omega. Right, that is called as a free speed, where no load is connected to the motor or the motor is not driving anything. But when you connect this motor to something, if you want to rotate some other object using this motor, the speed became half. Now we know that the EMF induced is directly proportional to omega based on EMF is equal to NBA omega cos omega t. Now if omega becomes half, new back EMF becomes 10 by 2, that is 5 volts. So what happens to the current? Is applied voltage is 12, back EMF is 5, divided by the resistance is 1, which will make it as 7 amperes. So the answer is 7 amperes.